The expression 5x minus 4 greater than 2x plus 3 looks like an equation, but with the equal sign replaced by an arrowhead. This denotes that the part on the left, 5x minus 4, is greater than the part on the right, 2x plus 3. We use 4 symbols to denote inequalities. This symbol means is greater than. This symbol means is greater than or equal to. This symbol means is less than, and this symbol means is less than or equal to. Notice that the arrowhead always points to the smaller expression. Inequalities can be manipulated like equations and follow very similar rules. But there is one important exception. If you add the same number to both sides of an inequality, the inequality remains true. If you subtract the same number from both sides of the inequality, it remains true. If you multiply or divide both sides of an inequality by the same positive number, it remains true. But if you multiply or divide both sides of an inequality by a negative number, it's no longer true. In fact, the inequality becomes reversed. This is quite easy to see, because we can write that 4 is greater than 2. But if we multiply both sides of this inequality by minus 1, we get minus 4 is less than minus 2. We have to reverse the inequality. This leads to difficulties when dealing with variables, because a variable can be either positive or negative. Look at these two inequalities. X is greater than 1 and x squared is greater than x. Now clearly, if x squared is greater than x, x can't be 0. So it looks as if we ought to be able to divide both sides of this inequality by x, giving us x greater than 1, which is what we've got on the left. But in fact we can't do this. These two inequalities are not the same. This is because x can be negative. Here we're saying that x is greater than 1, so x must be positive. But here we have to take into account the possibility that x is negative. In fact, the complete solution for this is x is greater than 1 or x less than 0. Because obviously if x is negative, then x squared is always going to be greater than x. I'll show you exactly how to get the solution for this type of inequality later on. Great care really has to be taken when solving inequalities to make sure that you don't multiply or divide by a negative number by accident. For example, saying that x is greater than y implies that x squared is greater than y squared only if x and y are positive. I'll start with a very simple inequality. X plus 3 is greater than 2. To solve this, we simply need to subtract 3 from both sides. If we subtract 3 from the left-hand side, we're left with x. If we subtract 3 from the right-hand side, we're left with minus 1. And that is the solution to the inequality. Inequalities can be represented on the number line. Here our solution is x is greater than minus 1. So we start at minus 1, and this line shows the range of values that x can take. And I'm going to put an open circle there. That open circle denotes that although the line goes to minus 1, x cannot actually equal minus 1, x has to be greater than minus 1. Let's have a look at another one. 4x plus 6 is greater than 3x plus 7. First of all, I'm going to subtract 6 from both sides. So I get 4x on the left greater than 3x plus 1. And now I'm going to subtract 3x from both sides, which gives me x greater than 1. And again, I can represent this on the number line. X has to be greater than 1, but x cannot equal 1. Another example is 3x minus 5 is less than or equal to 3 minus x. This time I need to add 5 to both sides, which gives me 3x is less than or equal to 8 minus x. And then I need to add x to both sides, which gives me 4x less than or equal to 8. Finally, I can divide both sides by 2, which gives me x is less than or equal to 2. And on the number line, x is less than or equal to 2, so we go this way. And this time I'm going to do a closed circle. This denotes that x can be equal to 2. Now I'd like to look at the inequality minus 2x is greater than 4. In order to solve this inequality, we're going to have to divide both sides by minus 2. So we get minus 2x divided by minus 2 is x. And I've got to remember, because I'm dividing by a negative number, to reverse the inequality. And 4 divided by minus 2 is minus 2. So I get x is less than minus 2. There's often more than one way to solve an inequality. And I'm going to solve this one again by using a different method. So we have minus 2x is greater than 4. If we add 2x to both sides, we get 0 is greater than 4 plus 2x. And then if we subtract 4 from both sides, we get minus 4 is greater than 2x. And we can divide through by 2 again, getting minus 2 is greater than x. And saying that x is less than minus 2 is the same thing as saying minus 2 is greater than x. So we've solved this inequality by 2 different methods. The second one avoids dividing by a negative number. Inequalities often appear in conjunction with the modulus symbol. For instance, we say mod x is less than 2. The modulus symbol denotes that we have to take the absolute value of x regardless of sign. This is just the magnitude of x, and it is always positive. So for instance, mod 2 is equal to 2, and mod minus 2 is also equal to 2. If the absolute value of x is less than 2, then x must lie between 2 and minus 2. We write minus 2 is less than x is less than 2. We can show this on the number line. X has to lie between minus 2 and 2, but it can't be 2 itself. This shows the range of values that x can take. If mod x is greater than or equal to 5, we have the absolute value of x must be greater than or equal to 5, which means that x is going to itself is going to be greater than or equal to 5 or less than or equal to minus 5. We write x less than or equal to minus 5 or x greater than or equal to 5. And on the number line, x can take the value 5 So we do a closed circle, and it can take the value minus 5. Now I want to look at another slightly more complicated modulus one. We have mod x minus 4 less than 3. The modulus sign shows that the absolute value of x minus 4 is less than 3. This means that x minus 4 must lie between minus 3 and 3. So we write minus 3 less than x minus 4 less than 3. This is what we call a double inequality, and we must treat it as two separate inequalities. So on the left we have minus 3 is less than x minus 4. By adding 4 to both sides, we get 1 is less than x. On the right, we have x minus 4 is less than 3, and again we add 4 to both sides to get x is less than 7. So the solution to this particular inequality is x is greater than 1, x is less than 7. We write 1 less than x less than 7. And again, I'll show you that on the number line. X lies between 1 and 7, but it can't be either. Now let's solve mod 5x minus 8 is less than or equal to 12. We're saying here that the absolute value of 5x minus 8 is less than or equal to 12. So 5x minus 8 must be less than 12 or greater than minus 12. We write minus 12 is less than or equal to 5x minus 8 is less than or equal to 12. Again, we have a double inequality. On the left, we have minus 12 is less than or equal to 5x minus 8. We add 8 to both sides, which gives us minus 4 is less than or equal to 5x. And then we divide both sides by 5, which gives us minus 4/5 is less than or equal to x. On the right, we have the inequality 5x minus 8 is less than or equal to 12. So we write 5x minus 8 less than or equal to 12. We add 8 to both sides, which gives us 5x is less than or equal to 20. And we divide both sides by 5, which gives us x is less than or equal to 4. So our final answer is minus 4 over 5 is less than or equal to x, which in turn is less than or equal to 4. And we can show this on the number line. Minus 4/5 is about here, and we go through to 4, and because it's less than or equal to, we use a closed circle. Inequalities can be solved very easily using graphs, and if you're in any way unsure about the algebra, it could be a good idea to do a graph to check. Let me show you how this works. We take the inequality 2x plus 3 is less than 0. Now this inequality can be solved very easily doing algebra, but it makes a good example. The first thing that we need to do is to draw the graph of y equals 2x plus 3. And I've got this graph here. Note that it's the equation of a straight line. It has a slope of 2 and an intercept on the y-axis of 3. On the x-axis, y is equal to 0, so that where the line cuts the x-axis, y is equal to 0. Above the x-axis, y is greater than 0, and below the x-axis, y is less than 0. So when we say that we want 2x plus 3 less than 0, on this graph that means y is less than 0, so we're looking for the points where the line is below the x-axis. In other words, where x is less than minus 1.5. And this is the solution to the inequality. And we can mark this on the graph using the x-axis as the number line. This technique can also be used with modulus inequalities, and here using a graph can be very helpful. Take, for example, the inequality mod x minus 2 is less than 0. Again, we need to plot the graph of y equals mod x minus 2. This is the graph of y equals mod x minus 2. For those of you who are not familiar with modulus functions, it might look a little bit strange. On the right, we have part of the graph of y equals x minus 2. And on the left, where x is less than 0, we have part of the graph of y equals minus x minus 2. This is because the modulus function changes the sign of x when x is negative. Again, we're looking for mod x minus 2 is less than 0. So we want the places where y is less than 0, which is between x equals minus 2 and x equals plus 2. And again, this is the solution to our problem. So we say minus 2 less than x less than 2. Again, we can mark this on the graph using the x-axis as the number line. Quadratic inequalities need handling with care. Let's solve x squared minus 3x plus 2 is greater than 0. Note that all the terms are on the left-hand side, and on the right-hand side we just have 0, exactly as with a quadratic equation before you solve it. This expression factorizes to x minus 2, x minus 1. Now if this was a quadratic equation, we would simply say, right, x equals 2 or x equals 1, and that's it. But we've got a bit more work to do here. Whether this expression is greater than 0 is going to depend on the sign of each of these two factors. We sort this out by using a grid. The points at which x minus 2 equals 0 and x minus 1 equals 0 are marked in. So this is 1 and 2. We put the two factors on the left and their product. Now, when x is less than 1, both x minus 1 and x minus 2 are going to be negative. So when you multiply them together, their product is going to be positive. When x is greater than 1 but less than 2, x minus 1 is going to be positive, but x minus 2 is going to be negative. So when you multiply them together, their product will be negative. Finally, when x is greater than 2, both x minus 1 and x minus 2 will be positive, and if you multiply them together, their product will also be positive. We are looking for x minus 2 times x minus 1 to be greater than 0. This occurs when it's positive, and our grid shows us that this happens when x is less than 1 or when x is greater than 2. So we write in our answer, which is x is less than 1 or x is greater than 2. And on the number line, x must be less than 1. So I put a circle to show that it can't be 1. And x can also be greater than 2. Here's another quadratic. Minus 2x squared plus 5x plus 12 is greater than or equal to 0. I don't like having a negative coefficient of x squared, so I'm going to multiply this whole thing through by minus 1, remembering to change the direction of the inequality as I do. This gives us 2x squared minus 5x minus 12 is less than or equal to 0. This expression factorizes to 2x plus 3 times x minus 4. So that is less than or equal to 0. Again, I'm going to do a grid. This factor is 0 when x is minus 3 over 2. This factor is 0 when x is 4. We write in the two factors, and we write in the product. When x is less than minus 3 over 2, both 2x plus 3 and x minus 4 are negative. So their product is positive. When x lies between minus 3 over 2 and 4, 2x plus 3 is positive, but x minus 4 is still negative. So their product is negative. When x is greater than 4, both 2x plus 3 and x minus 4 are positive, so their product is positive. We are looking for 2x plus 3 times x minus 4 to be less than or equal to 0. In other words, this expression has to be either 0 or negative. This occurs when x lies between minus 3 over 2 and 4, and it can equal either number. So we have minus 3 over 2 is less than or equal to x is less than or equal to 4. And on the number line, minus 3 over 2 is here, and 4 is here. And I've done filled circles because we have less than or equal to. Quadratic inequalities can also be solved graphically. Let's solve x squared minus 3x plus 2 is greater than 0. As with the linear inequalities, we have to plot the graph of y equals x squared minus 3x plus 2. This factorizes to give y equals x minus 1 times x minus 2. The graph looks like this. Because it's a quadratic, it's a parabola, a U-shaped curve. And it crosses the x-axis where x equals 1 because of the factor x minus 1, and where x equals 2 because of the factor x minus 2. Now we're looking for x squared minus 3x plus 2 to be greater than 0. This is where y is greater than 0. In other words, the part of the graph that is above the x-axis, which are the two arms of the U here. This occurs where x is less than 1 and where x is greater than 2. So we can write that in as our solution. And we can mark this in using the x-axis as the number line. I'll do one more quadratic inequality. X squared minus x minus 6 is less than or equal to 0. Again, we need to plot the graph of y equals x squared minus x minus 6. The expression factorizes to x minus 3, x plus 2. And the graph looks like this. Similar to the previous graph, we have the factor x plus 2, the line crosses the point at x equals minus 2. And for the factor x minus 3, the curve crosses the point at x equals 3. And we're looking for where x squared minus x minus 6 is less than or equal to 0. In other words, y must lie on the x-axis or below it, this part of the curve, and that occurs between the points of x equals minus 2 and x equals 3. So we can say that minus 2 is less than or equal to x, which is less than or equal to 3. And we can plot this in, again using the x-axis as the number line, from minus 2, using a closed circle because minus 2 is included, to plus 3.